Welcome to the Retro Hack Shack. I'm Aaron Newcomb. On today's episode, I'm going to be continuing my exploration of the Apple IIc. Now, if you haven't seen parts 1 and parts 2, you'll want to go back and do that because we looked at the history of the Apple IIc. I tested the Apple IIc, cleaned the Apple IIc. We made discs for the Apple IIc. We screen printed from a special card, and we even caused a fire with the Apple IIc. No, I'm not kidding. We actually caused a fire, or I did anyway. That was in part 2. So anyway, I'll put a link to those videos in the up above and in the description below. So if you haven't watched that yet, I highly encourage you to go back and watch parts 1 and 2. It'll set you up really nicely for what we're going to be talking about today, which is we're going to be taking a look at hooking up a modem to the Apple IIc and connecting to some BBSs. Then we're going to check out an external disk drive for the Apple IIc. And finally, we're going to be connecting HDMI to the Apple IIc. So this is hopefully the last in the third part because we've covered a lot of ground. Also, I had some comments on the last video with people saying there wasn't enough Penny in the video. So I just want to let you know that Penny is here. She's sitting down here on the floor. And to prove it, I can cut to camera 2. And you can see here's Penny laying down nicely. She is getting bigger. She's up to about 33 pounds, I believe, right now. Last time I took her to the vet. So she's getting super big, and she stays in here with me while I'm doing my soldering and my recording and all that kind of stuff. She just loves to be around people. So there's Penny. But anyway, it's coming up right now on the Retro Hack Shack. So to start out with today, let's take a look at this. Whoops, fell off. I was going to take that off for you. But yeah, so this is the other half of the 5-DIN cable that I made on the last episode. Remember, I used half of this to make this other cable, which we used to make some floppy disks. The difference is, I said it was basically the same, but it's not. As you can see, there are different genders on the 9-pin DIN. So the one that I use to make floppies with is a female 9-pin DIN. The one that I use here for the modem connection is a male 9-pin DIN. And the reason is because I want to use this on more than just this particular unit. I want to be able to use this for PCs and other things that need a male 9-pin DIN. So I used a little bit different connector on this end. And that just plugs into what I want to talk about, which is this modem, ESP 8266 modem thing that I built using some great software, which I'll talk about in a minute, that was not written by me. Come on, you. I don't want to break my case. There we go. Let's take a closer look. Okay, so that's about as close as I can get it. We're going to take a look at how I built this using KiCAD in a minute, but I just wanted to give you a visual look at this first so you'll have some reference. There's the ESP 8266 on a chip here, and then there's some jumpers here. Of course, there's the 9-pin DIN on this side. In the middle here, there's some stuff for power and some pull-down resistors. There's a USB. This is a micro USB. That's just for power. There's no data flowing through that. And then there's a reset and a flash button. And on the back, we have a little chippy. And I'll show you what this chip is in just a minute, because I can't read it. It's so small. Make sure this is in focus. I also have what the pinout on the other side does, right? So I've got all of the various connections here that you might need. There's programming connections, and there's also the RS-232 signals that are all broken out here. And then, of course, my little name on the back there. So on this particular board, essentially what it is it's an ESP 12E, which is an ESP 8266 on a chip, or on a board, I guess. And most of the other stuff you see on here is just to make sure that the ESP 8266 will come up and work properly. So for example, there's certain pull downs you need on the reset lines and on some of the other GPIOs, GPIO 0, 12, 15. They all need to be either pulled up or down for the ESP8266 to start correctly. So most of this board is just getting the ESP8266 to start up and run programs correctly. So all of these resistors down here, the resistors down here, we've got power with some decoupling caps. It's pretty basic stuff in terms of electronics, nothing really special going on there. And then we just have, like I said, that USB micro jack to just provide power. So there's ground and 5 volts coming in there. I'm going to be talking a lot about RS-232 signals and how I connected those to the ESP32. However, I'm not going to go into great depths to explain what all those signals are. If you want to find out more details about RS-232, just do a simple Google search. There's plenty of information out there on the web. Oh, and look, there's a picture of that modem I used for my Knight Rider hack. Cool. On the ESP8266 itself, you can see there's a number of GPIO pins, and I've labeled those with what the signals are going to be connected to those. So TX, RX, these are all the RS-232 serial connections that you're going to need in order to make this work. So mostly what you're going to need on these older systems is just TX, transmit, RX, receive, and ground. But there are some cases where certain software will be looking for certain handshake signals, for example, and that's what the rest of these things are: CTS, RTS, DTR. There's RI for ring. So sometimes certain software will wait to hear a ring before they kick in and start going to the next level of the software and so forth. And the way that I came up with these is I looked at the program that I used. And I'm going to get into this more in a minute with how the software works, but just to show you a little bit of the code, I'm not going to go into great detail, but if you go down here in the code that I used, you can see the first thing that it does is define which pins are for which signal. So for example, if I go down, here's ESP32, and then here, is the ESP8266, and the default pin, for example, for DSR is 13. The default pin for DTR is 12. These are GPIO, the GPIO pins here. So if I go over here, we can see that sure enough, here's GPIO 13, which is physical pin 7, which maps out to DSR. So it's just kind of a mapping game initially to get these things to coincide. And then I added this connection down here, like I said. This connection is set up so that DTR and DSR go together. So if you wanted to loop DTR and DSR back, just create a loopback path, you would just put a jumper across pins 2 and 4, and that would make it look like whenever a DSR signal was sent out and was expecting a DTR, for example, it would just be a loopback, and it would see itself basically on that line. So that's what I did with that, and they're all like that. If I want to send, for example, RTS and CTS, those are the handshake signals, I believe, and you can just loop those back to the source, and it'll look like whenever it asks for one, it'll get an acknowledgement back, because it's just it's like looking in the mirror, basically. In this case, it's just like, oh, are you there? Yep, I'm there, but I was the one that said, are you there? So that's basically how that part of it works. Okay, so that brings us to this big box here, which represents that chip that I was showing before, which is the MAX 3232. And you'll see that this is connected to the transmit and receive lines. The reason that we need this is because, let's just take a look at the data sheet here. RS-232 typically operates at 12 volts, but the ESP8266, the GPIO lines run at 3.3 volts. And so what this chip does is it basically translates the receive and transmit. On one side, it's 3.3 volts, and on the other side, it's 12 volts. And this could be used, I believe, it says here, could be used with 3 volts or 5 volts. And that's about it. Let's just take a quick look at what the board looks like in KiCAD. And here it is. If you've never seen KiCAD, I kind of want to do an episode on how to design something in KiCAD, but I'm not an expert. I just kind of hack around. But my goal here was to get this as small as possible. And as you could see, it was indeed pretty small. I didn't want to have a big clunky board. I wanted to get things as tight and neat as possible. And I believe I achieved that. So we can take a look at the 3D view here. Here it is. And here's the 3D view from KiCAD. I like to import all these 3D models so I can really get a sense for like, oh, how hard is this going to be to solder? Is this little, am I going to be able to get to this power regulator here and actually solder that in by hand? Things like that. And having this 3D view is really nice to try to figure out what this is going to look like in the end. So I think it came out pretty well. And then I just designed a simple 3D printed case for it. And yeah, I like it. And you can use it with all sorts of different retro gear. So not just the Apple IIc, but you could use it for, well, if you made the correct adapter, you could use it for a Commodore 64. You could use it for an IBM, lots of different systems. If you really want to learn how to use KiCAD, I highly suggest taking a look at the channel called Contextual Electronics. Chris Gamble has a ton of videos. He's big into KiCAD, and he takes you through like how to do a basic design, how to use KiCAD, what everything means, how to do things like, setting up your the correct configuration for your Gerber files, which are the files you have to send to the fab to have them design your PCB. So if you're new to KiCAD and you want to get started with a free open source PCB design software, I would highly recommend taking a look at this channel. It's really great content, and it's how I started when I started getting serious about designing things in KiCAD. I went here first and went through all the tutorials, and now I can jump in pretty much any day of the week and just jump in and kind of get going and design a board. There's always questions, but there's a great community around KiCAD that'll help you if you're having any issues. Okay, now let's take another look at the software before I put this thing through its paces and we connect to a few BBSs here. The project is called Z-Modem, Z-I Modem, and it's by Bo Zimmerman. So if you go to GitHub and you search for either of those, you should find this project. And this was, I think, originally created to run on a C64, so C64 net Wi-Fi firmware. It's right there in the name. But like I said, it works with all different systems. And there's a lot of just great information right here on the GitHub page. I'm going to skip the building stuff because I don't want to go that deep in this video. But essentially what I wanted to do was get into the usage. Or actually, let's start at the top here and just talk about what this is. So essentially what he's done is he's created software that runs on an ESP8266 or ESP32, which are microcontrollers that simulate AT commands that were used in old style modems. So it's acting as a translation layer between what the computer thinks is a modem connected to the serial port and the internet. So what it allows you to do is it allows you to stream in telnet mode. So you can connect to a modern BBS through telnet over the internet, because this also allows you to connect to your Wi-Fi network. And then the computer thinks it's talking to the modem. The device translates that, goes out, talks to the BBS and brings it back and translates it back to the computer. And it works really, really well once you get it set up. And if you are old enough or are interested in learning what it was like back in the day to use this use an old retro computer with AT commands, this is a great way to do it, because most of the commands are supported, but he's also introduced commands that allow you to interact with the device from the terminal, which is super helpful, to do things like call out, set up your preferences so it knows which website to connect to or which telnet session to connect to when you dial a fake number, right? Like 555-1212. And probably one of the most valuable commands, the one you're going to want to use first when you first get things set up and running, is this AT plus config command. That gives you a little interface where you can actually configure the baud rate, your Wi-Fi name and password, all that kind of thing, so that you can get kind of up and running. So AT plus config is the thing you're going to need right away to kind of get things working for you. It also allows you to do some common things like turning echo on and off. Not all programs echo your what you're typing back to you on the screen, and that can be annoying, but you can go into the terminal and just type in a command. In this case, ATE1 or ATE0, you can turn echo on and off. Like I said, it includes an address book, so you can have a bunch of different fake numbers, if you will, and then you associate that with a web address, and every time you put in that number to dial, it'll actually call the web address for you over the Wi-Fi and connect to the BBS that way. There's some other really cool features that are worth mentioning. For example, once you set your baud rate on the modem, the default is 1200, but let's say you want to run at 9600, there's a command in here that lets you save the configuration, or you turn echo on and off, for example. Any of that stuff that you set, you can just hit this command. Oh, hello, Penny. You can hit this command and type this command and it'll save that configuration for the next time, even if you turn the power off, which is really cool. You can also do automatic firmware updates. I'm sure I'm running an old version of firmware, but if you type in this command AT and U, it'll check to see if there's a newer firmware version available, and then the code right below it will actually update the firmware from the home page on the web, which is really, really cool. So the first, I'm going to check out two different software packages. The first is Apple Access 2. And the thing I like about this particular communications package is it's very basic, and sometimes basic is better. In this case, it's nice because I've got it booted up here on the screen, and I apologize, I'm connecting this over composite, and it's in 80 columns mode. The quality is never good over composite on 80 columns mode, so perhaps I can check this out on an RGB monitor just so we can see what it looks like there after this if there's time. But anyway, I'm just going to quickly show you a couple of software packages, and you can use these to connect to modern BBSs. People are still running BBSs, believe it or not. You can connect to a BBS using this software and the Wi-Fi modem, and you can recreate that BBS browsing experience if you remember it or if you have fond memories of it. So anyway, I like this program because it's basic. What I can do is just go to terminal mode. I don't have to configure really anything in this software. Let's just go to terminal mode, and it'll bring up a terminal, just a blank terminal. There's nothing to show when you first go in here, but I can go ahead and hit AT and make sure that the modem is responding. There we go. Now we're getting an OK back. I've already pre-configured some numbers in the modem. So let me dial up a website essentially. If I type in AT plus config, you'll see there's a menu that comes up, and you can use this to actually set your settings, change your settings. And you can see I've added two phone book entries, they call them, in here, right? So there's one for Particles BBS, and there's one for the Dura, I forget what it's called, Dura something BBS. Let's try the Particles BBS with this though first. Okay, and as you can see, when I type in ATD and then the pretend phone number, it actually just translates that to the address. It connects to that address on the web. So I hit return, and we should be connected to Particles. ANSI detected. All right. No, it's not. You can see those characters at the top there. Those are ANSI characters for drawing graphics, and apparently it's thought it detected an ANSI terminal, and this is not an ANSI terminal. It's just a text terminal. Okay, and we're into the Particles BBS. There's online games, ANSI support, although my terminal apparently does not do ANSI. Okay, I put in all my information, and it's looking for new news and connecting me to the service. Unfortunately, this is going to get in the way, these ANSI characters. It's just not going to look right. Let me see if there's any way to change this to ANSI mode. I don't believe it supports ANSI mode, but let me just check real quick. Yeah, and so Apple Access, just to note that Apple Access does, I found it in the menu, it does support ANSI mode, it says, but it definitely wasn't registering those characters. So let's try ProTERM and see how we do there. You'll notice that, when you boot up into these programs, they automatically set 80 columns mode for you, so you don't have to use the button on the front. So that's kind of nice. Here we are in 80 columns mode. Now you'll notice when you first set this up, it asks you like what kind of modem. I just picked a 9600 baud compatible modem for this, but it doesn't really initialize the modem like it expects to, but that's okay. It lets you just select online. And then you have to flip over the disk because this program's too big to fit on a single disk. So I've recorded, there's a front side and a back side. And a lot of these programs came with their own dialing setup, of course, which is the way you would expect to use this back in the day. But here, we're actually not using that because we're using the modem's built-in commands to dial it. So you just open up a session typically with a blank number, a blank phone number if it lets you, and that drops you into the terminal. Once you're in the terminal, you can use the settings that you've programmed into the modem, the Wi-Fi modem to make your connection. So here we're just going to go ahead and do dial and do a quick dial. This is a little bit more complicated, which is why I said I like the access a little bit better for doing this quickly. But here we're going to just change the baud rate to 9600. And say dial with no number. Okay, now we can just confirm that the modem is working by hitting AT. Should get back okay, and we do. Now, before I connect, this does support ANSI mode, I believe, mostly properly. So let's go ahead and turn on ANSI mode by going into some of the options here. But if I go over here, there's actually a couple things. There's actually a ProTERM special emulation, and there's ANSI. Let's try the ProTERM special because I think that does a lot of the same things as ANSI does. Whoops, there it is, ProTERM special. And then just say okay. And then we can dial our number, 8675 309. There we go. Checking for ANSI. Checking for ProTERM. Yay, ProTERM special. Here we go. Okay, so this is kind of working. I'm not an expert in ProTERM. I didn't use it back in the day, obviously, because I didn't have an Apple, but we are connected to Dura Europos. Okay, and I'm in. System news. A new Petski game is available. And now you can see I'm in, and I can browse around, see what's going on. Hey, it's got my username now. That's pretty cool. Oh yeah, here's some games. So what should I try to play? I want something simple. Maybe Biteman 17? Oh yeah, it is working. And there's the little, instead of a Pac-Man, there's a little apple icon. That's hilarious. Let's see what happens when I get caught. A ghost caught you. Game over. That's pretty funny. Of course, it's a text mode version of Pac-Man, and this is what you could do on a BBS back in the day. Very cool. So just a quick look at how you can use that same serial port and that same cable we made earlier to connect to a Wi-Fi modem and connect to BBSs. Pretty neat. Okay, the other thing I thought would be fun to test in this episode is this drive that I picked up on eBay. This is the external drive. You know, most Apple IIs, the full-size Apple IIs, when people got disk drives for them, they usually got two so that they could copy disks back and forth because there really wasn't any hard drives in these. So with the Apple IIc, when you got that, you got one drive included, which was unique, as I mentioned on the last video. But if you wanted to copy stuff back and forth, you needed a second drive. And so they released this drive. This is the, here it is. This is the Disk 2C. This, I believe, came out at the same time as the Apple IIc did. It's model number A2M4050. And yeah, so this would have been, you know, it looks very similar. In fact, I'm sure that the drive itself is the same as this drive, and the mechanism works the same way. You know, if we hold this up, I mean, it's just big enough to fit an Apple IIc, the same drive as this. And in fact, if you look on the back again, you can see that it has the same 4 screws which hold this drive in place from underneath that we saw when I disassembled the Apple IIc. So I'm sure it's the same mechanism, or pretty sure anyway, with some added electronics perhaps that are needed just to maybe for power regulation or something. I don't know. So I thought I got this for a reasonable price on eBay because it was listed as not working. So either, maybe there's a blown fuse or something simple. That's what I'm hoping anyway. Maybe it just works. Maybe the owner didn't know how to make it work with the Apple IIc. So in any case, we'll find out. Penny, you think this disk drive is going to work? Maybe. Maybe. It might work. What do you think? I figured a good way to test this out would be to, since you can't boot from the second drive, this is going to be registered as slot 6 drive 1. This will automatically be slot 6 drive 2, and I don't believe you can change that. It's hardwired. So we won't be able to boot from this drive, but what we can do is we can go back to the ADT Pro software that we made when we were making disks in the last episode. And remember, there's a volume menu, or on the menu there's a volume function which lists the volumes that you have available to you. So let's pop this in and bring up the volumes and just see if we can see this external drive. Okay, here we go. Now, no light on this drive, so it didn't, like a PC would normally go through and scan the drives and see if they're there, at least send a command to them. No light came on this, so that's not a good sign, at least I would assume there'd be some sort of light when you powered this thing off, like even a momentary blip on the LED here. So anyway, here's ADT Pro. Let's go ahead and select serial. And here at the main menu, let's go ahead and do volumes. Oh, the light just came on. It came on briefly, and we've got an I/O error. Okay, well, at least that's something. Let's put a disk in and just see if it'll read it. So here's that same Summer Games disk that we used on previous videos, so we know this works in this drive. Let's see if it comes up in this drive. If we hit R to refresh here, rescan, and no, it comes up with I/O error, so that's not good. Let me just go ahead and clean this drive before we take it apart. You never know. Maybe the heads are just dirty or something. My handy dandy Alsop cleaning disc. And I'm just going to put a little bit of IPA on here. Get it pretty well saturated. And then I'm just going to, by hand, I'm going to move this around about 180 degrees. Do this a couple times just to make sure there's several places that have some IPA on here. And you have to do this relatively quickly because it will evaporate. There we go. That should be good enough. And I'll hit rescan again. Obviously it's not going to find anything, but I'm just going to keep rescanning, I don't know, 3 or 4 times. And just make sure those heads are clean. Okay, so that's done. I'm going to take the cleaning disc out. I don't really see any I don't see any dirt or anything that, we may still need to go in and do a manual cleaning, but let's go ahead and put in a blank disk and just see if it'll format. Well, there's some good sounding activity there. It looks like it's trying to format. Format another? No. Let's take a look at the volumes again. Oh, and now it says blank. Let's rescan and see what it does. Yeah, it's coming up fine now. Okay, so when I put Summer Games back in and hit rescan, it comes up with I/O error. Let me put the ADT Pro disk in there and see what that comes up with, because we know that should come up with ADT Pro, yada, yada, yada. Yeah, it does come up with ADT Pro just fine. So I think the summer games might be a little bit of a fluke. It does seem to be reading the disk. Okay, so what I've done is I have made a disk using that transfer method I showed on part 2 of this series. Anyway, I created a copy to plus disk that I can hopefully use to copy some files back and forth and then compare whether it's actually writing the files correctly. So I've never used this software before, so bear with me. I may look like an idiot here for those of you who have used this in the past. But what I thought I could do was I could copy these summer games files over to that blank disk I made before. So the initial disk is in here. I'm just going to take it out and we'll see, because I think I need to put the summer games disk in to be able to copy. That makes sense, right? So hopefully the copy to plus program is loaded into memory. So I'm going to hit copy. I'm going to say disk. Let's see what happens. Select the source device. So the source device is going to be drive 1. Target device is going to be drive 2. Insert disk and press return to continue. That's interesting. So it's having a problem reading summer games. Maybe there's a problem with the disk. Okay, so I'm going to try a different source disk. Let's go ahead and try Oregon Trail. Disk 1, and let's just see if that will copy over. Copy. We're going to copy the whole disk. Source is drive 1. Destination is drive 2. Let's see what happens. Okay, this is sounding better. Okay, well this enclosure definitely makes this drive sound louder than this one. But it does look like it's working. It read the tracks and now it's writing the tracks. It says it's done. So now let's see if it'll boot Oregon Trail off that disk we just made. With any luck, this will boot Oregon Trail. Yeah, here it goes. Looks like it's working. So this unit, even though it was listed as not working, is totally working. There is a problem with that copy of Summer Games, which is kind of interesting. Maybe I set that too close to something. I don't know. But this is actually working just fine. So I got lucky that time. So now I have a nice second external disk drive. Before I finish up this segment, though, we still need to take a look inside and compare, what's here in this drive with what's in this drive here. So let's do that. Okay, so I've removed the screws. And let's take the cover off. Ta-da! Exactly what I thought. That is the exact same mechanism. Exactly what's in here. All they've done is the same ribbon cable that's coming out of the back of this and plugs into the motherboard. They've just extended that. I don't know if you can see. Cable comes in, wraps around, and just goes to that drive. Period. End of story. That is all it is. It is exactly the same drive as what's in the Apple IIc. So no mystery there. Okay, so if you remember when we were doing the testing of the Wi-Fi modem, some of the screens were a little blurry, and that was because we were in 80 column mode, which caused those screens to be a little bit blurry because I was using the composite output. So I was thinking, for one last thing I could test on this Apple IIc, wouldn't it be nice if we could get HDMI out and clean those screens up so that they would look, really nice, and we could really get a clear view of what those screens said. So of course, I'm going back to one of my favorite projects, the RGB to HDMI, which I've done, I think, 4 videos, and I think I've got a 5th one coming, potentially. So I looked it up to see if this project would support a standard composite out, and it does. So all I did was I made up a new cable. You can see it here. Basically, all it is I connected the video signal to the center pin of this RCA jack, and then all the other signals went to ground. There is something to keep in mind. If you're going back and taking a look at those videos, I'll put a link up above. You need to be aware that there is 5 volts coming off of this board, and that is for when the system has 5 volts to power the Pi. You can hook up that 5 volts and make it work. But in this case, there's no voltage involved. It's just the signal. So I went ahead and cut off that part of that strip of the cable here so that it didn't make any connections. All right, so I've got that set up. So let's plug it in and power it up and see if it works. All right, I've got my HDMI connected, and I'm just going to power up the Pi, and we'll see if we can get any output on it. Fingers crossed. There we go. Looks like it's powering up. Got the little rainbow thing. No sync detected, but there's the menu. So before I actually turn on the Apple IIc, let's go ahead and change the settings. I think there's one in here for Apple. Let's see. Right now it's set to Acorn Atom, which I think is the default. Let's see if we can find Acorn. Oh, there we go. Apple II. And I need to change, you can see here there's a sub profile. I need to change that to 60 Hertz. That looks better. So there we go. So assuming that I don't have to do anything else, let's turn it on and see if it works. Here we go. Hey, look at that. Excellent. No blurriness, perfectly sharp pixels, perfect aspect ratio. Everything looks great, as always with this project. This is such a great project to get clear video out. It certainly helps me when I'm trying to capture stuff. I should have done this first. Then all of the stuff I did before when I was capturing video would have looked crystal clear. Okay, so let's try to start up. I believe this is monochrome only, but let's go ahead and put in Oregon Trail and start that up and see what it looks like. Here we go. Oh no, it does color. Look at that. Out of the box. Wow. I didn't expect that. I thought it would be monochrome only on that because I just had that one pin. Look at that. That looks great. Oh, I definitely should have done this first. Oh, that's too bad. Because look how crystal clear that is. That is awesome. Let's just go through a couple of these so you can get a feel for the way this looks. Banker from Boston. Yeah, look at that. Wow. That looks great. Okay, so let's now stick in the one of the terminal programs and see what it looks like in 80 column mode. Okay, so here's Access, that really simple terminal program, but it was pretty clear to see the effects of the blurriness of the composite signal. So let's just go ahead and start up Access and see what that looks like. Hopefully this works in 80 column mode. I have no idea. I assume it does. Hey, there we go. 80 column mode. There's a little bit of a sync issue because I can see a little bit of fuzziness on the screen, but this is already better. Let's see if we can fix the sync issue and make it look perfect. If I go down here to auto calibrate video sampling, that should work. It's going to go through all of the different phases, come up with the best one where there's the least amount of errors. It looks like maybe 3, 4, and 5 are all okay. Let's see what we get. Yeah, that looks better. That looks better. I'm not seeing any of those fuzziness anymore. So yeah, simple auto calibration, and this looks great. I don't have the modem hooked up, but I could hook it up. Okay, I just booted things up here. I booted up the modem. It does look like it's working. Let's just do a quick test. It looks fantastic, by the way. Let's go ahead and just do a quick dial into a BBS. Five 5551212 connected particle. Now this time I turned ANSI emulation off since it wasn't working. Let's see if it detects that. Okay, there we go. So now we're in text mode. You can see what that looks like in text mode. It's got the particles BBS there, blah, blah, blah. Enter member handle. Oh, I don't remember what my member handle was. Was it Retro Hack Shack? And my password, I'm not sure what that was either. Okay, it's working. So there you go. I'm just going to leave it there just to give you an idea of what this looks like. But man, sticking HDMI on this thing is fantastic. I know that people love to, put their screens on have it exactly the way they used to have it. But boy, switching this to HDMI is really nice in 80 columns mode. I know it would be good too on RGB out, because this does have an RGB out, and I do have an RGB monitor actually that I could have tested, but I am missing the cable right now, so I couldn't hook it up. But in any case, that is working. So 2 big thumbs up for HDMI output on the Apple IIc. If you want to see the rest of my HDMI series of getting HDMI on retro computers, go check it out. It's worth it. And these things are worth their weight in gold. These little HDMI to RGB to HDMI modules that you can build yourself. Highly recommend them if you have some soldering skills. If you don't, you can actually buy them through the website. Occasionally people will make them and sell them for a few bucks. So very, very cool. Every time I hook up the RGB to HDMI adapter to a retro computer, I am amazed at how good it looks. It just doesn't seem possible that you can get that quality out of that board. If you haven't seen my other 4 or 5 episodes that I've done on that, you can check those out in the description below. So there'll be lots of parts in the description that you can go check out for more videos. But it really is incredible, and I'd encourage everybody to get involved. Don't just consume, but also give back. Go to that project page, see if you can help out, maybe with documentation or with some code, whatever it is that your specialty is. See if you can help out with that project, because it benefits the entire retro community. I'm also really glad that I was able to connect to a few BBSs. I'm sure that brought back a lot of memories, and it was really nice now to have a second disk drive for the Apple IIc. I'm still looking for a replacement top after the fire in the last video.
Cool. Fire, 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 fire.
So I'm looking for a top cover for the original Apple IIc. There was 2 created. There was one with the detachable backplate and one without. And I'm looking for the one with the detachable backplate. That was the original one. There's been a couple offers in the comments below, but if you have an Apple IIc that is damaged but has a good working top to the Apple IIc, let me know. Or if you come across a place where I can find one, leave that in the comments or send me an email. Either way is fine. If you want to keep up with what I'm doing in between episodes, you can check out my Instagram or my Twitter page, where I post pictures and updates on things, projects and things that I'm working on. You can also subscribe, of course. That always helps get the word out, and it helps make sure videos are showing up in your feed. You can like the video if you found it at all useful, and you can support me on my Patreon page. And I really, really am grateful for all the patrons out there who make these episodes possible. So with that, thanks for watching. We'll see you next time. If you want to support me on Patreon, you can go to patreon.com/retrohackshack and sign up.
End of line.